Okay, here is number 5, one of our second proofs on the study guide. Let's look at what we need to prove first. So I'm going to put that in green. I need to prove that line B in green is perpendicular to line M. Well, the only way to get that to be proven is to prove that angle 4 is a right angle. That's the only way I could get perpendicular lines. So we need to think about how I'm going to use all those other 3 givens to lead into proving that angle 4 is a right angle, and then I could say B is perpendicular to M. Okay, so let us look at the first given, L parallel to M. L parallel to M. Here's their transversal right there. Alright, well the only 2 angles I see there that are labeled as angles 1 and 2. What's special about them? They are corresponding angles. So I'm going to say then that angle 1 is congruent to angle 2 because corresponding angles in parallel lines are congruent. Okay, now let's take a look at the next given. A parallel to B. I'm going to erase that red. Okay, now A and B is going this way in blue, and here's their transversal. So something that I do notice, if you kind of turn and look at it, is that 2 and 4 seem to be right on those A and B parallel lines, and they're also corresponding angles. And what I like about that is that angle 2 seems to be in common between both things there. So let's see what happens if I do that. Angle 2 is congruent to angle 4. And again, it's the same reason. Corresponding angles of parallel lines are congruent. Angles are congruent. So now let's all take a look at number 2 and number 4. Well, look at that. They're both congruent to angle 2. So what does that tell us then? That tells us, by the transitive property, that angle 1 is congruent to angle 4, transitive. Now, is this kind of making any sense here? Because I'm trying to get angle 4 to be 90 degrees somehow, so we're getting close here. Okay, now, let's use the last given. A is perpendicular to L. Given. Okay, let's erase this blue stuff here. Erase everything again. Okay, now let's look at A perpendicular. A is perpendicular to L. Alright, so looking at that, if you notice here, it has there, we know that angle 1 is a right angle because of perpendicular lines. So I'm going to say that the measure, oops, let's do that in black, that the measure of angle 1, I'm supposed to say that angle 1 is a right angle. That's definition of perpendicular lines. Definition of perpendicular lines. And then number 8, I'll say the measure of angle 1 is 90 degrees. Definition of a right angle. Now, how does that help us? Well, now I could take that result from the transitive property, and I could say the measure of angle 1 is equal to the measure of angle 4 because congruent parts have equal lengths. And once I do that, now I know that the measure of angle 4 is also 90, because if you notice here in number 8, we know angle 1 is 90, and we know they're both the same, so I could definitely say by substitution that the measure of angle 4 is 90 degrees. And that's what we wanted to prove from the beginning, correct? If you look back up here, we wanted to prove, let's erase this again, we wanted to prove that B was perpendicular to M to get angle 4 to be a 90 degree angle. So we just did that. So now number 11 is going to say that angle 4 is a right angle. definition of right angle. And now I can finally say then that B is perpendicular to M, definition of perpendicular lines. We have our right angle there. Oops, perpendicular lines. So that was a big proof. That was 12 steps here. Hopefully you guys understood kind of the flow of the stuff. And again, any questions, just ask me or Mr. Reed.